Hello students, welcome again. So in our last video we had completed about Mendeleev's periodic law, and in this video we are going to see about modern periodic law. Okay. So modern periodic law, what this law states that the properties of the element are dependent on their atomic numbers and the element shows similar properties at regular interval of increasing atomic number. Now what this law means? This law means that my elements, if I'm taking any element, that element will show the similar properties. Element will show similar properties at a regular intervals. When I will increase the atomic number of that elements, then it will show a similar properties at a regular interval of a time. So this law states that the property of elements are totally dependent on their atomic number. As my atomic number increases, the properties also increases of the element. Now, modern periodic table, after Mendeleev's periodic table, modern periodic table was formed and it was designed by Henry Moseley. You can see over here, it was designed by Henry Moseley and it had 7 periods and 18 groups. Okay, in Mendeleev's periodic table, there were rows and groups. Okay, here also there are periods and groups. There are 7 periods and 18 groups in modern periodic table. All the limitations of Mendeleev's periodic table were overcome by modern periodic table. Okay, that if somehow Mendeleev's failed of some elements, where then that elements were fulfilled by the modern periodic table. Now, modern periodic table is based on Moseley's periodic law. That was Mendeleev's periodic law, and this is Moseley's periodic law. That is atomic numbers dependent on the atomic number. Now what he suggested, what Moseley suggested, he suggested that increasing of, instead of arranging element in ascending order of their atomic mass, they should be arranged in ascending order of their atomic number. Now, Mendeleev said that elements should be arranged in ascending order of atomic masses. But according to Moseley, the elements should be arranged in ascending order of their atomic numbers, not masses, numbers. Number of electrons in an atom is equal to atomic number Z. Now, in atom, the number of electrons which are present, they are equal to atomic number Z. Now, this law is an empirical law which concerns that X-ray emitted by atoms, which concerns the characteristic of X-ray which is emitted by the atoms. The frequency of X-ray, the frequency is V of X-ray which is emitted by the atom, it is related to atomic number Z. By the formula, you can see the formula V is equal to root of A minus B. Here A and B both are constant. You can see V is frequency, A and B are constant. So this is the periodic law, Moseley's periodic law, modern periodic table which we are considering till now, and it is the successful table which we are studying till yet. Now classification. Now you can see over here periodic table, but there are some classification. It is classified into various types. There are 4 ways. It is classified into 4 ways on the basis of their electronic configuration. Now first one is noble gas elements. Noble gas element. In this periodic table, there are noble gas elements. You can see the color which is shown over here. The element filled with this color are the noble gas elements. Okay, so noble gas element are the element of group number 18 of modern periodic table. Group number 18, the last group is the 18th group. This is the 18th group and it is noble gas elements. Electronic configuration of the first element, that is helium. You can see helium. The first element is helium. The electronic configuration of first element helium is 1s2. Rest all the elements, that is neon, argon, krypton, xenon and radon, have their outer shell electronic configuration in ns2 np6. Now you can see over here helium has sp2, 1s2 configuration. Rather than this, all neon, argon, krypton, xenon, radon, all these elements will have electronic configuration ns2 np6. Now this we study further in our next videos in detail. Till then you can just remember that electronic configuration of this outer shells is ns2 np6. As the octet of these elements is complete, as the octet of this element is complete, they are highly stable elements. Now octet means what? 8. Total number of circles of which are formed of the element are 8, that are called as a octet. Now octet is complete for all these elements like neon, argon, krypton, xenon, radon. For all these noble gas elements, they have completion of octet. Their outer shell is completed, so they are the highly stable elements. Second is representative elements. Now S block as well as P block, they both come under the category of representative elements. You can see over here, this is S block, P block. So these are the blocks which are divided. So S block and P block elements comes under the representative elements. Element in the group 1 and 2 are S block elements with 1s2, 2s2 outermost configuration. 13 to 17 are P block elements. You can see over here, elements with group 1, group 2 comes under S block. Element with group 3 to 7, 13 to 17 will come under the P block elements. Okay. Now next are transition elements. So we had seen two type of element, noble gas elements, that is group 18 elements. Representative elements can be S block as well as P block, that are S block comes under group 1 and 2 and P block 13 to 17, whereas transition elements are the element which belongs to group 13 to 12 and have electronic configuration as n-1 d1 minus 10n S1 to 2, and they are referred as a transition element. Elements are known as a T block elements. Okay, so SPD, SDP. Okay, S1 for S elements, S group is element 1 and 2. 13 to 17 will come under P block, and 3 to 7 3 to 12 will come under the D block. Now next are inner transition element, that is lanthanide and actinide series, which is seen over here. Lanthanide and actinide series. You can see here lanthanide as well as actinide series comes under the inner transition elements, which falls at the bottom of the periodic table, come under the category of inner transition element. In this element, 4f and 5f orbital are partially filled, rendering their special properties. You can see the table which is below of the periodic table will comes under the inner transition element, that is lanthanide and actinide series. Okay. So we had seen the periodic table, modern periodic table, Mosley's periodic table. This table we will be studying in details in my further videos. This was just a reference purpose, and you had seen about the classification. There are 4 types of classification. Noble gas elements comes under, group 18 comes under noble gas elements. S block as well as P block comes under the representative elements, and transition element are 3 to 12, that is D block elements, and inner transition are the lanthanide and actinide series. So we had completed our topic, that is modern periodic law. Modern periodic law was designed by the Henry Moseley, and table consists of 7 periods and 18 groups. This was described after Mendelev's periodic table. So this is the modified version of Mendelev's periodic table. I hope you got my video and you don't have any kind of a doubt. If you have any kind of a doubt, you can ask me. Okay, till then, thank you.